Cardinal number of a finite set. That's a cardinal number of a finite set. The distinct element of a finite set is a cardinal number of finite set. It is denoted by Na. So actually cardinal number means number of member of that particular set. For example, in set A we have 1, 2, 3, 4, 5. Then cardinal number of the set means number of member of that particular set. 1, 2, 3, 4, 5. So cardinal number of this set is 5. Let's discuss about few formulas related on cardinal number. N A union B. I will explain the formula comparing it with Venn diagram, so it will be easier for you all to remember it. Suppose we need to find out the value of A union B. N A union B. A union B means, as we have already discussed before, A union B means either the member of A or the member of B or the member of both. So N A union B means N A N B. So while adding N A and N B, we have counted this middle person twice. This middle person means the part of the intersection of A and B. So we need to subtract once. Minus N A intersection B. Similarly, to find out the value of N A intersection B, what we do, we will bring A intersection B in front. Then N A plus N B minus N A union B. Suppose you need only A and only A. And only A means from A, only A means this portion only. So from A, what we need to do, we need to subtract this middle person. This middle person is minus N A intersection B. Similarly, to find out N only B, what we can do, N B minus N A intersection B. From B, we need to remove the common part which is common with A. Now, for N A union B complement. For the complement of any set, complement of any set means beside that remaining member of the universal set. So, complement of A union B. A union B means members of A and members of B and member of both. That means A union B is this circle part. So A union B complement means from U we need to subtract A union B. Similarly, for N A complement, this means beside A remaining part of U. So NU minus NA. Likewise, for NB complement, what we can do, NU minus NB. Complement of any set means beside that remaining member of that universal set. For complement of A intersection B from universal set, what we do, we subtract NA intersection B. So this is what we have to do. And NU, to find out universal set, NU it means all the members of A, all the members of B, intersection as well as the complement part. So to find out NU, what we do, N A union B plus N A union B complement. That means members lies either in A or in B or in both, or those members which is not in A union B but it is in universal set. of a group of 120 students, 90 take mathematics, 72 take statistics. If 10 students take neither of the two subjects, how many take both? So first of all, we need to write down the given part as total number of students NU equals 120. So 90 take mathematics. Number of students take mathematics. Suppose NM is 90 and 72 take statistics. That means number of students take statistics. NS equals 72. Now what if 10 students take neither of the two? As I have already told you before, neither of the two means complement of the union. Number of students take neither of two or don't take. N M union S complement is 10. So how many take both? So we need to find it out. Number of students who take both the subjects. N M intersection S equals what? So here, to find out intersection, we have formula N A intersection B is NA plus NB minus N A union B. So for that, first of all, we need A union B. We know total number of students. We know how many do not like any of the subjects. So we can easily find out how many like either the one. So for that, what we need to do now, for N M union S equals NU minus N M union S complement. So from total number, if we subtract students, those who don't like any of the subjects, we can easily find out how many like either one. So we have 120 in NU and 10 don't take any of the subjects. So 110 is M union S. Again, N M intersection S equals now NM plus NS minus N M union S. So NM we have 90 plus in NS we have 72, and just now we found M union S is 110. 90 plus 72, 162 minus 110, 52. Now therefore, number of students take both subjects, we found 52. Therefore, 52 of them take both the subjects. Now, to solve the sums related to three different sets, we have one formula, N A union B union C. How can we find out when we have three sets? So, we should add NA plus NB plus NC minus NA intersection B minus NB intersection C minus NC intersection A. While subtracting intersection, we have subtracted the intersection of all three. That's why we need to add that part, because union means common as well as the remaining all. So this is the formula to find out NA union B union C. Now for this questions, let's begin with the given part, NU, total number of person is given 500. 285 was football. Number of people who watch football 285. 195 was hockey. NH is given 195. 115 was basketball. NB is given 115. 45 was football and basketball. Football and basketball. Football intersection basketball 45. 70 was football and hockey. Football and hockey F intersection H 70. 50 was hockey and basketball. Hockey intersection basketball is 50. 50 do not was any of three games. Neither football, nor hockey, nor basketball. 50 of them do not like any of the game. How many watch all three games? How many watch all three games? That means F intersection H intersection B we need to find out. And together what we need to find out, how many watch exactly one of the three games means how many of them watch only football and only hockey and only basketball. That means sum of only football, hockey and basketball we need to find out after this. Here, before to find out N F intersection H intersection B, first of all we should find out F union H union B. Here we have given the total number of people and we have given how many do not like any of the game. So if we subtract how many do not like any of the game from the total, we can find out how many like either one. So N F union H union B equals NU minus N F union H union B complement. Now NU we have 500 and we have the complement of all three sets is 50. So 450 is F union N F union H union B. Now to find out N F union H union B, we have formula NF plus NH plus NB minus NF intersection H minus NF intersection S minus F intersection B minus NH intersection B plus NF intersection H intersection B. So let's replace the value of F union H union B, which is 450 equals NF we have 285 plus NH we have 195 plus NB we have 115 minus NF intersection H we have 70 minus F intersection B we have 45 minus H intersection B we have 50 plus intersection of all sets we don't know to write as it is F intersection H intersection B. Now let's calculate this equals sum of 285, 195 and 115 is 595 minus sum of all three 70, 45 and 50 165 plus NF intersection H intersection B. Here we have 450. Now 450 equals difference between 430 plus NF intersection H intersection B. Now NF intersection H intersection B equals 450 minus 430, which is 20. Therefore NF intersection H intersection B is 20. Just now we found NF intersection H intersection B is 20. Now we need to find out how many was exactly 1. That means only F, only H and only B. If we fill up the value in our sets, it will be easier for us. And F we have 285 and H we have 100 and H we have 195 and B we have 115. Similarly, F intersection H we have 70. I'll write it down inside only. F intersection H 70. Then F intersection B. The intersection of F and B is 45. Intersection of B and H is 50. Intersection of all three, just now we found 20. Now, what we need to find out? We need to find out N only F. N only F means only this portion. So we know total is 285 and F 70, 20, 45. All three lies in NF, but we need pure F, excluding these three. So what we need to do? We need to add those three terms, 70 plus 20 plus 45, and subtract from 285. 285 minus 135 equals so N only F, number of people who like only football is 150. Now we need to find out N only H and N only B. Before that, if we fill up that set, it will be easier for you. We have 285 in NF. In NH we have 195. We know how many of the like F in what is F intersection H? F intersection H is given 70, but here we have already 20 over here. So yeah, 50 comes over here. So to find out N only H, from NH we need to subtract. From NH we need to subtract this N only F intersection H minus N only H intersection B minus N only F intersection H intersection B. To find N only H, NH minus F intersection H, H intersection B minus N, F intersection H intersection B. NH we have 195 minus N only F intersection H, N F intersection H 70, as we have 20 here, here is 50, minus N only H intersection B. H intersection B, we have 50, 20 is there, minus 30, and all three intersection we have 20. So equals 195 minus 50, 30, 80, 20, 100. So 95 is N only H. Similarly, for F N only B, N B minus N only F intersection B minus N only H intersection B minus N only F intersection H intersection B. So NB we have 115 minus N only F intersection B. F intersection B we have 45, 20 is there, so 25 minus N only H intersection B. H intersection B we have 50, 20 is there, so remaining 30 minus intersection of all three is given 20. So 115 minus 25, 30 and 20. 45 minus 45, 55, 65, 75. So 0. 115 minus 75 is 40. So now we know N only F 150, N only S 95 and N only V 40, which we want. What we need to find out, how many was exactly one of the 3 games. Now to find out how many was exactly one of the 3 games, we need to find the sum of N only F plus N only H plus N only B, which is 150 plus 95 plus 40 equals 295. So therefore 295 of them was exactly one of the 3 games. Exactly one of the 3 games. That's it.